Remember that we're following the integration what to do and when flowcharts when approaching integration questions. And remember that you've got the formulae in the formula book to help you as well. So, question 22. We want to work out the area under the curve x to the power half ln 2x between the limits of 1 and 4. So we're going to integrate between 1 and 4, x to the power half ln 2x with respect to x. I'm going to do this with integration by parts because I know that when I differentiate that ln, it's going to become much simpler. So let me select that to be my u. And then I'll select the v dash to be the x to the power of a half. Differentiating the ln, I'll get 1 over 2x, but then times by 2 because of the chain rule. The 2's will cancel and that will just give me 1 over x. Integrating the x to the power of a half, so I'll add 1 to the power and divide by the new power. So I'll get 2/3 x to the power 3 over 2. Using the by parts formula then, we'll have u times v minus the integral of u dash times v. I now notice that within this integral here, those x's are going to cancel out. So we'll just have 2/3 and that 3 over 2 take away 1 is a half. And now I can do that integration reasonably easily. So we're going to add 1 to the power to get 3 over 2. We're going to divide by the new power, which is the same as timesing by 2 over 3. So we'll get 4 over 9. Our limits were 1 and 4. So let's substitute each of those in, starting with the 4. 2/3 of 4 to the power 3 over 2. ln of 2 times 4 is 8. Then substituting the 1 in. Okay, so let's go through each of these. The square root of 4 is 2. 2 cubed is 8 times 2 over 3 is 16 over 3 ln 8. We can simplify that logarithm. I'll do that in a moment. Then we've got the square root of 4 is 2. 2 cubed is 8 times the minus 4 over 9 is minus 32 over 9. Then we've got 1 to the power anything is just 1. So we'll have the just the minus 2/3 ln 2. And then the 1 to the power anything is just 1, so we'll have the minus 4/9. The ln 8 is the same thing as ln 2 cubed. So let's turn that 8 into a 2 cubed. Which then means I can bring that 3 down to the front and multiply to get 16 ln 2. Let's deal with these brackets as well. We've got the minus 2/3 ln 2 and the minus minus, so a plus 4/9. Collecting up the like terms then, we've got 16 ln 2 minus 2/3 ln 2. Those are like terms, they can be collected together, which will be, that's the same thing as 48/3, so we'll get 46/3 ln 2, and then collecting up the fractions, we'll get minus 28/9. And that's the simplest I can write my answer. Question 23. We need to show that the integral of sine 2x over 1 plus cos x dx between 0 and pi/2 is 2 plus ln 2. First thing, this sine 2 theta, I noticed that the 2 theta is not the same as the theta on the bottom, so I'm going to do something with that double angle. So let me rewrite my numerator as 2 sine theta cos theta. Right, it's still looking pretty tricky. There's nothing that cancels just yet. So I'm thinking about making a substitution here to try and make this a bit simpler. Substitution I'm going to try, well, it'd be nice if we got rid of the denominator, so maybe if I could say u equals 1 plus cos theta, that might make it a bit simpler. Let's try that. Let's differentiate. Let's say du by d theta. The 1 will disappear, the cos will differentiate to be minus sine. Make d theta the subject. Like that. So I'm going to replace the d theta here with the minus du over sine theta. Which I can see that's going to cause some simplification. Because if I just write this out first, and then we'll see the simplification. So the d theta has been replaced with minus du over sine theta. And now we can see the sine theta here and the sine theta here, they're going to cancel out. Then we just need to deal with this denominator in the u world. We know is just u because of here. And then this cos theta here, well, I know that's going to be the same as just u minus 1. Right, what about the limits? So, let's do that here. When theta is 0, u is equal to 1 plus cos 0, which is 2. So our lower limit here is 2. When theta is pi over 2, u equals 1 plus cos pi over 2, which is 1. So my upper limit is 1. Right, I'm going to swap these limits around, so this bigger number is on the top and the smaller number is on the bottom. I'm allowed to do that as long as I change the sign on the inside to be positive. I'm also going to expand the brackets to be 2u minus 2 over u. I'm going to split that division up. 2u over u is 2. 2 over u is 2 over u. And now we can integrate. 2 will integrate to be 2u. The 2 over u will integrate to be 2 ln u. Substituting the limits in, so 2 times 2 minus 2 ln 2 minus 2 times 1 minus 2 ln 1. So 4 minus 2 ln 2 minus 2. The ln 1 here is just 0, so that's going to disappear. And we'll get as our answer 2 minus 2 ln 2, which is in the form required, where a is minus 2.